Good morning, students. In today's lesson, our topic is writing expressions and equations through patterns. At the end of the lesson, you will be able to use pattern as a tool to write and evaluate numerical expressions, algebra expressions, and equations. You might be wondering why you need to learn all of this. Later on, you will be exposed to functions. And one big idea, the big idea in function is the concept of change. So here, with the use of pattern, we will be looking at the changes that take place in each stage. And then we're going to use those changes to develop um, numerical expressions, algebraic expressions, and equations. So let's start. Here we have a pattern. As you can see, you have three stages. Stage one, we have one. All right, we have one green tile and then you have two red tiles. So in order for us to write the total number of tiles, we're going to write the sum. So 1 plus 2, the sum of the green tile and the red tiles. So that would be a total of 3. For stage 2, we have one green tile again. The number of red tiles is 4. And the numerical expression for that, to get the total number of tiles, will be 1 plus 4. In total, we have 5 tiles. Stage 3, we have one green tile, and then the number of red tiles is 6. And the numerical expression for that will be 1 plus 7. And that would be equal to, 1 plus 6. And that would be equal to 7. Now, what about stage 4? How does it look like? Do you think there will be one green tile? Let me write one green tile. And what about the number of red tiles? So let's go to Didact's virtual manipulative. So in this application, we can continue to stage 4 and stage 5. So we have one green here, right? So I'm going to continue. So if you can see, in stage 1, you have one red tile on the top, then 2. In stage 2, you have 2 red tiles on the top, and stage 3, 3 red on the top, red tiles. So I'm going to assume that there should be 4 red tiles on the top. And on the side of the green tile, stage 1, you have 1. Stage 2, you have 2 red tiles. Stage 3, 3 red tiles. So there should be 4 red tiles on the right side of the green tile. All right. And now, stage 5, again, there should be 1. Okay, let me put it here. So I don't have enough. So what I'm going to do is I'm going to do a screenshot. I'm going to capture this. And then I'm going to paste this in our slide. So I'll make it smaller. So for stage 4, yes, I have one green tile. And then the number of red tiles will be 8. And the numerical expression will be 1 plus 8 will be equal to 9. So what about stage 5? Look what is changing and what is not changing. So the number of green tile is not changing. It's constantly 1. While the number of red tiles, as you can see, is increasing by 2. 2, 4, 6, 8. So I'm going to put here 10. So for stage 5, I am assuming that there should be 1 plus 10, which is going to be 11. Now, I can rewrite 1 plus 2 with an equivalent numerical expression, because I noticed that the only number that does not change is 1, but 2, 4, 6, 8, 10 are even numbers. So I can rewrite these even numbers as 1 plus 2 times 1. And then this will be equivalent to 1 because 1 is not changing, but 4 can be expressed as 2 times 2, which is 4. And then 1 plus 6 will be equivalent to 1 plus 2 parenthesis 3. And 1 plus 8 will be equivalent to 1 parenthesis 1 plus 2 parenthesis 4. And for stage 5, 1 plus 10 will be equivalent to 1 plus 2 times 5. Now, let us observe. Stage number 1, my numerical expression is 1 plus 2, which is equivalent to 1 plus 2 times 1. Stage 2, 1 plus 4 is equivalent to 1 plus 2 times 2. Stage 3 is 1 plus 6, which is equivalent to 1 plus 2 times 3. And stage 4, 1 plus 8, which is equivalent to 1 plus 2 times 4. And stage 5 is 1 plus 10 is equivalent to 1 plus 2 times 5. Now, here, the numbers that do not change are 1 and 2. Now, 1, we can say that 1 is the green tile. Now, how can you relate 2 with our diagram? And how can you relate 1, 2, 3 with our stages number? So, if you look at 2 here, on each stage, we have 2. Where is 2 in the diagram? So we can say that there are 2 groups of 1, because you have 1 here, 1 here. For stage 2, there are 2 groups of 2. And stage 3, you have 2 groups of 3. Stage 4, you have 2 groups of 4. And stage 5, you have 2 groups of 5. So now, for any number, I will assume that there should always be a 1, but I do not know the number of red tiles. But based on the expression here, I will look at this expression here and relate the numbers that do not change are 1 and 2. So I'm going to write 1 plus 2. But the number inside the parentheses changes. Now, how does it change? Look at the stage number and look at the number inside the parentheses. So if the stage number is 1, the number inside the parentheses is 1. If the stage number is 2, the number inside the parentheses is 2. If the stage number is 3, the number inside the parentheses is 3. If it is 4, it's going to be 4. And if it is 5, it's going to be 5. So therefore, if it is n, which means any number, then that would be also the number inside the parentheses. So now, I have an algebra expression for whatever stage number I'm going to have. All right, so that would be for any stage number, the total number of tiles will be 1 plus 2 times n. That would be my expression. for the total number of tiles. Now, the equation will be, so I'm going to insert an equation. So if the total number of tiles will be represented by t, all right, that would be my variable to represent the total number of tiles. So let me insert the text box. So t, in order to determine the number of tiles for any stage number, then t will be equal to whatever expression we have at the bottom, which is 1 plus 2 times n. So let's say I would like to know how many tiles there are for stage 50. So stage 50, that means n is equal to 50. So I'm going to use our equation. Total number of tiles will be equal to 1 plus 2 times the value of n. Okay, I'll make it small. The value of n is 50. So therefore, let's evaluate. 1 plus, we have to multiply 2 times 50, which equals 100. Then I have 101 tiles, total tiles for stage 50. All right. So I have here another pattern, and I would like you to complete the table. Let me see how you're going to complete the table. All right. So you use the Didax application for the virtual manipulative to create stage 4. You can also create stage 5. And then you complete the table. You should be able to have numerical expression, equivalent numerical expression. You must have the variable n, which means for any stage number. And then you must have the expression in order to determine how many total tiles there are for any stage number. Then you must also have your equation and then assign any number for n and then evaluate your equation so that you will have the value for the total number of tiles. All right, so have fun.